12.2 Vectors in 3 dimensions. A three-dimensional coordinate system is created by adding the z-axes perpendicular to the x and y axes. In deciding the positive direction of the z-axis, we have two choices. So it is important that there be agreement in the direction of the positive z-axis. And we will use the conventional right-handed coordinate system. If the fingers of the right hand are curled from the positive x-axis to the positive y-axis, the thumb points in the direction of the positive z-axis. The xy plane, xz plane, and yz plane break three-dimensional space into 8 octants. In the first octant, x, y, and z are all positive. To find the point 3, 4, 5, move 3 units in the positive x direction, 4 units in the positive y direction, and 5 units in the positive z direction. The point -2, -3, 5 has the same z direction, up 5 units, but moves 2 units in the negative x direction and moves 3 units in the negative y direction. Y equals 4 is now the equation of the plane parallel to the xz plane and 4 units away. Z equals 3 is the equation of the plane parallel to the xy plane and 3 units away. The midpoint between P and Q is made up of the averages of their components. And finding the distance from P to Q requires 2 uses of the Pythagorean theorem. We use the Pythagorean theorem to find the equation of a sphere and the inequality that represents the ball. The positioned vector v1, v2, v3, shown in black, has its tail at the origin and its head at the point v1, v2, v3. Suppose we have 2 points P, Q, and we would like to find the position vector for PQ. Well, v1 is just going to be x2 minus x1, and v2 will be y2 minus y1, and v3 will be z2 minus z1. The position vector v1, v2, v3 is also equal to all vectors such as rs that have the same length and direction as v. The length of PQ can be found using 2 runs of the Pythagorean theorem. There are 3 coordinate unit vectors in 3-dimensional space: I pointing in the x direction, j pointing in the y direction, and k pointing in the z direction. So the vector v1, v2, v3 can be written v1i plus v2j plus v3k. Suppose a plane is flying horizontally due north in calm air at 300 miles per hour when it encounters a horizontal crosswind blowing southeast at 40 miles per hour and a downdraft blowing vertically downward at 30 miles per hour. The plane is flying horizontally due north in calm air at 300 miles per hour. So v sub a, the velocity of the plane relative to the air, is 300 j. The plane encounters a horizontal crosswind blowing southeast at 40 miles per hour. So W, the crosswind, is going to be 40 times the cosine of negative 45-degree angle times I, plus 40 times the sine of that same angle times J. So W is equal to 20 radical 2I minus 20 radical 2J. The plane encounters a downdraft blowing vertically downward at 30 miles per hour. So D, the downdraft, is negative 30 K. Summarizing this, a plane is flying horizontally due north in calm air at 300 miles per hour. So V sub A equals 300J. When it encounters a horizontal crosswind blowing southeast at 40 miles per hour, so W, the crosswind, equals 20 radical 2I minus 20 radical 2J. And also a downdraft blowing vertically downward at 30 miles per hour, so D equals negative 30K. Find the resultant vector V. To find V, all we're going to do is add these three vectors. And of course we want to add them component by component. When we do that, V is equal to 20 radical 2I plus 300 minus 20 radical 2, all of that times J, minus 30K. Take care. Have a good day, and I'll see you in 12.3.